Okay, so we are headed into Lesson 9, Multiply and Divide Integers, and I really want to encourage you to get all your sign laws under control. The biggest thing I can say is as people move into my beginning algebra, intermediate algebra, college algebra, and calculus courses, as you will see on iTunes, you can find them all. First thing I ask my students, in beginning algebra is I say, do you have your sign laws under control without a calculator? Do you know that -7 times -7 is positive 49 without a calculator? So let's make sure we have our rules under control. Here we go. If you're looking to memorize a rule, here it is. The product of two numbers having the same sign is positive, and the product of two numbers having different signs is negative. It's that simple. So what do we mean by that? So here you have a negative number times a negative number. They carry the same sign. So negative times a negative is a positive. So 5 times 3 is 15, and -5 times -3 is 15. Like signs. So people say like signs is going to return a positive answer with the operation of multiplication. Well, here, these are unlike signs. You've got a -3, but you're multiplying that with a +4. So negative times a positive returns a negative. So -3 times 4 is -12. Likewise here, you have unlike signs. So this is a +6 multiplied with a -8. You're going to return -48. So now we can memorize this rule, but we do want to think about why. We're going to look at some number patterns up here in a moment. And this last one, obviously, positive times a positive returns a positive. 7 times 3 is 21. So if you just think of it in terms of signs and no numbers, positive times positive returns a positive. Negative times negative returns a positive. That's what we mean by like signs. Here, negative times a positive returns a negative. Positive times a negative returns a negative. So you do have to devote that to heart. Now, we can also, through the use of number patterns, we can also look at, why that might be. So let's take something that you've known since you were little, right? You've known 3 times 2 is 6. Well, let's just 2, 1, 0. Now over here, what I'm going to do is keep this, I'm going to hold this 2 constant, and just think about the number pattern. Okay, so you know that 2 times 2 is 4. You know that 1 times 2 is 2. You learn your times tables pretty young. But look at the number pattern itself. Now look at what happens here. 3, 2, 1, 0. Just solely pattern-wise, what should be the next number in the list? Okay, -1, right? 2, 2, 2, 2. Next number in the pattern would be a 2, right? Here, 6, 4, 2, 0. It looks like it keeps going down 2. Well, then what's the next number? If I'm at 0 and I go down, I'm going to be at -2. So basically, this implies that a negative times a positive will return a negative, which is exactly what we said. Negative times a positive will return a negative. So solely by looking at, a number pattern, you can see that a negative times a positive must return a negative. Okay? And in a very similar manner, what you can do then is extend that from there. Okay, now if you believe that -1 times 2 is -2, then what you can do is start changing this number. Take it down by 1. Okay, -1 times 1 would have to equal -1, because anything times 1 is itself. Okay, but now let's start to look at the number pattern. Again, think about just pattern recognition. Okay, this is -1, this is -1. The next number would still be -1. This is a 2, this is a 1. You'd have to go down 1, to get 0. And we know that anything times 0 is 0. Okay, so let's continue the number pattern. Next, this number is a -1. Aha, 2, 1, 0. What's the next number down? -1. Well, here, -2, -1, 0, we're going up. We go up 1. Well, then this would imply that a negative times a negative returns a positive. So this would imply that a negative times another negative is going to return a positive. So just by pattern recognition, you can kind of think through why something is what it is. Most people devote these rules to heart. Okay, so let's take note then. We know a negative times a negative is a positive. But then a negative times another negative would return a negative. So we're starting to feel like the product of an odd amount of negative numbers is negative, and the product of an even amount of negative numbers is positive. Knowing this will help us evaluate a string of multiplication quickly. i.e., just count the number of negative signs in the product, and you'll know whether your end result is positive or negative. So let's play with this one together. So I see a string of multiplication, right? 1, 2, 3. I see 3 negative signs. Note to self, that's an odd number of negative signs. So I know from the get-go the end result, see, the product of an odd number of negative signs is negative. So I know from the get-go the end result is negative. Now all I have to do is just focus on multiplying sort of the absolute values of the factors themselves, the positive form of the numbers. So in other words, just focus on 3 times 4. You already know the answer is going to be negative in the end, so just focus on the positive numbers. So 3 times 4 is 12, times 2 is 24, times 5 is something. I'll do that off on the side, is 120, and then 120 times 5. Is 600. So the final answer there is negative 600. But see, what's nice is we can think through that in our head without using one of these. We want to think through it without using a calculator. Okay, this course is all no calculator. Now, of course, when you're at home, you can check your end result on a calculator, but I really, really want you to think through this without touching any calculator. We have to build that part of the brain. Let's try again. Negative times a negative times a negative times a negative times a negative. How many are there? So 1, 2, 3, 4, 5, 6, 7, 8. Aha! 8 negative signs. Well, that's an even number. So we know the final answer is going to return, it's going to be positive. And since, it's a whole string of 1s, so you know that if you take 1 times 1 times 1 times 1, you still get 1. So voila, just 1. 1 is the final answer to that. Okay? So you don't, it's nice. You don't really have to, people get so dependent on a calculator, you don't have to type in a whole string of negative 1s, You just know that you've got an even amount of negatives, it's going to return a positive 1. Also know that you could express this as negative 1 to the 8th power. So notice that it could be expressed like that, and you've got an even power. All right. Now let's take a look at division. Dividing integers, I like to think of multiplication and division as sort of brother-sister operations. They've got really the same rules going on there. Division is obviously related to multiplication in the following way. We say that 6 divided by 2 is 3, but that's because, notice this, that's because 3 times 2 is 6. And we say that 6 divided by negative 2 is equal to negative 3, but notice why. That's because negative 3 times negative 2 is 6. So we know that you can always check a division problem via multiplication, right? Well, then one would suggest, or one would think that the same rules apply. Like if the product of like signs is positive, then the quotient of like signs is going to be positive, and that's exactly what happens. So if you're looking for a rule, it's just like the rule for the products. The quotient of two numbers having the same sign is positive, and the quotient of two numbers having different signs is negative. So a negative divided by a negative returns a positive divided by a positive returns a positive, etc. And a negative divided by a positive returns a negative. See, you've got unlike signs, dividing unlike signs, and positive divided by a negative returns a negative. So we have to devote that to heart so that we can cruise right along. So let's try these without a calculator. Now here, you've got a negative divided by a negative, so you know it's going to return a positive. So I always say it's beneficial to determine the sign of your result before actually doing the math. And now do the math. Just think about, in other words, think if the negatives weren't even there. What's 12 divided by 3? 4. So it's like you're dividing their absolute values. 12 divided by 3 is 4. You already know it's going to be positive 4 because even if you want to note to self there, you've got like signs. Okay? Try again. 8 divided by negative 4. Well, it's unlike signs. You know it's going to return a negative. And you know 8 divided by 4 is 2. So you know the final result's going to be negative 2. So you just have to think through whether your end result will be positive or negative before you actually perform the division. So, all right, next one, negative divided by a negative, we know returns a positive. And 125 divided, and then we can go ahead and divide their absolute values. So 125 divided by 5 is 25. So we're going to return a positive 25 there. And last but not least, you've got a negative divided by a positive. Those are unlike signs. You know it's going to be negative. And 14 divided by 7 is 2. So we're going to end up with negative 2. So you really, really, really have to get those signs under control. Now I will mention, say this last one, negative 14 divided by 7, you could key it into a calculator. See, negative 14, parenthesis, divide by 7. You could key it in, and obviously you see the calculator's returning a negative 2 there. But like I said, just listening to what the calculator says is, it's not really testing your knowledge of signs. So we don't want to get dependent on that calculator. But indeed, negative 14 divided by 7 is negative 2. Okay, so to summarize, in short, positive divided by positive returns a positive. Negative divided by negative returns a positive, like signs. If you have different signs, positive divided by negative is negative. It's going to return a negative. And negative divided by a positive is going to return a negative. And I hope that helps. Let's see if we have any other thing. Nope, nothing else on our guided notes, but I hope to upload more examples in the future. Good luck out there.